L is the circumcenter. So this is the angle between this orthocenter and circumcenter and one side. So that should be the angle between this orthocenter and circumcenter and this side. So yeah, that's a very, very nice solution. All right, so here is a problem from Korea. So we have a cyclic quadrilateral, ABCD, and AD meets BC at a point. So let's draw it more like this. And the circle, and then we draw the line through A parallel to DB and BC. So what's the best way to draw this? Let's see. So yeah, I want to make AD horizontal just to make it look nice. This is point P. Yeah, this could be an easy problem, so we'll see. I just don't know yet. So we have DB and BC, and we draw the lines through A parallel to both of those. DB and BC. So it's almost like we have a, whoops, like a little homothety here. So homothety at P would take this triangle to this triangle. And we want it to meet this, but we want it to meet the circle at E and F. So DP, I think I drew that right. So E and F. I'm just going to, out of curiosity, draw these two other points right here, just so we have a homothety. I don't know if it's really going to help that much, but we'll see. So PA is equal to PX. All right. That's kind of interesting. So this is X. And we want to show that BE, CF, and DX are concurrent. Looks kind of like Pascal's theorem, but not 100% sure yet. So this is PX. PX equals PA. Okay. All right. Make it look a little nicer. Okay, so we have GF and A. And is that it? I think so. All right, so we want to show that BE, CF, and DX are concurrent. It almost looks, well, looks a little like projective geometry. Because, yeah, that would help us use the two parallels. So maybe we could show that, so if we intersect BE and CF, well, maybe what we could do is we could draw DX, and then we could try to show that both BE and CF cut it in the same ratio. I kind of like that idea, because let's see. Can we show that BE and CF cut DX in the same ratio? What would be a good way to do that? So let's see. So if we project through E, well, yeah, because the problem is DX isn't parallel. So maybe there's a better way to do this. Hey, John. Could you put your mic on mute? until you start speaking. Thanks. All right. No worries. Okay, so we have to use that PA equals PX. Yeah, this is an interesting one. Because yeah, it's not that clear how to use that fact. We could try drawing a center of the circle. Oops. So PJ is perpendicular to XA by symmetry. Okay, so these are parallel to those. BF is parallel to CE. Let's think about that. So AF is parallel to CE. Okay, so that must just be a calculation of angles, right? Because arc FC is arc AB, and arc AB is equal to arc DE. So yeah, that must just follow from that. Okay. So BF and CE are parallel. Good observation. Yeah, this is a tricky one. I wonder if I can make E. So this way E and F are both like on the same side of AD. That might look a little nicer. Of course, the problem could be either configuration, really. Yeah, and I don't really know if I need this point H. I'm just keeping it just for the heck of it, but yeah, I don't really know if I need it. So AE and AF are parallel to DB and DC. Oh yeah, that makes it really clear that these should be parallel, right? Because these angles are equal, so they intercept equal arcs. So BE and CF are just the diagonals of this isosceles trapezoid, and we just need to show that the diagonals intersect on dx. So now it looks a lot more symmetrical. I like that idea. So another way to phrase it is dx passes through. Let's think about this. So yeah, I like it this way better. So yeah, we draw these two diagonals, and we want to show dx passes through that point. That's pretty interesting, actually. Because really, I wonder if there's like a way we can just reformulate the problem. So we could say like, you have like a trapezoid, and then you have just some other point on the circle. And then you just draw these parallels, and they should, through F and E, and they should meet at another point on the circle. And then you just want to show that Vx passes through that. So that's like another way we could formulate this. You just have to use PA equals PX is the key here. You have to use that. We know JI is perpendicular to BF and CE. Maybe there's no way XI and D are collinear. I'd be very surprised. Is that true? XI and D are collinear? Wait. Huh. Wait. Am I just confusing myself? Or is that really true? I think it's true. Oh wait, that's what we have to prove. Look at me, I'm just going crazy. All right. I am losing my mind. So I don't know if this will help. And then JI passes through the midpoints of both of these, FB and EC. So yeah, any way we can use Pascal's theorem? Do FD and AB meet on EC? It almost looks like it, but no. It's just a coincidence. So maybe we could rewrite this problem. We could rephrase it as we let DI intersect the circle at X prime. And then we want to show that PX prime equals PA. What do you guys think about that? I kind of like that way of doing it. because then basically we have like a trapezoid, and you could let D be wherever you want, and then you need to just show that PA equals PX prime. DDIT. I'm not sure. Maybe that would work. Okay, so yeah, so how do we show that P?
I think we should not strictly use DDIT, but involutions. So I will remind you of one theorem about involutions, and that is that if we have like these 6 points on circle E, F, X prime, B, and C, and actually we will define X as in the problem.
Okay.
Then if we have an involution which swaps X and D, E and B, and C and F, then those 3 lines concur, which we need to prove. So there is also a thing that we can project an involution from, in this case, a circle to a line. So I suggest that we like intersect all those lines which would go through A and some line. For example, line BC.
Okay.
And then we need to prove that there is an involution at that line, which would swap like all of these pairs.
Okay, so EF, BC, and DX. That's what we want to show, right? So E and F we have, B and C, and so it's really just
E and B are pairs, C and F, and similarly D and X.
Okay, so I'll take all those points and I'll project it on the line BC, and then we just have the point we need to show HGK, BC, and P. There's an involution, right?
Yeah, and also an important thing is that any involution on a line is an inversion.
Inversion.
You should keep that in mind.
I wonder.
Also, it may be actually better to project maybe onto line BD, just because E would go to infinity.
Okay.
So that looks like nice.
Okay, so let's try projecting onto BD. So E would go to infinity. B and D stay where they are. And do we project through A?
Well, we can project wherever we want, but I think A looks like a good option.
Okay.
But it has to be on a circle.
Okay. So E and F. E goes to infinity. F would go to this point up there. Sorry. X, B, and then we'd have to draw this. Okay. So, sorry, I'll make it look better, but basically we're saying this point, so DNBLM, we're saying is involution, or it swaps M with the point at infinity. So I'm trying to think of this. So are we saying this?
I think it swaps B with infinity.
Swaps B with infinity. Oh, you're right.
Since B and E are involution pairs, yeah.
So is it the same as showing Bn times Bm is Bd times Bl?
Exactly.
Okay.
So this looks nice.
Okay. Okay. All right. Let me. Whereas if we did this one, then we'd have to show it some inversion about some other point, right? We can try something here. Oh, you know what? So it looks like these concur. I think that's. Oh yeah. So like I wonder. So basically, so I was thinking about using line BC. So basically, it's like we want to show that these 5 points are actually HGK, BC, and P. I think we want to show as an involution. But
For which one?
so basically, I was thinking about using the involution, but projecting onto BC. So then we want to show HGK, BC, and P is an inversion, or there's some inversion that swaps those.
Yeah, okay.
But so I didn't solve it, but we know that like we have like a homophily at P takes BC to GH. So I don't know if that makes it easier at all. But yeah, that's just what I was thinking.
Yeah. Okay, probably helps. Not sure though.
Okay. But I forgot what N is. Oh, that's just where AC intersects BD. Okay. Okay, so we want to show Bn times Bm is Bl times Bd. That's one way to do it. So yeah, these 3 lines are parallel to these 3 lines. I think that's probably useful because then cross ratios are equal, right? Or if we found some 4th line, let's say AB, then yeah, then we could have we basically have an equality of cross ratios. So basically, the cross ratio BCOA is equal to the cross ratio EFXD. Oh, isn't that enough? Well, wait, the cross ratio BCOA is equal to EFXD. I wonder if that's like enough that those 2 cross ratios are equal. So Yeah. Let me think about this for just a sec. So I think, hey Ryan, so we're in our second problem and we're trying to use involutions here. But yeah, so let me write this out what I saw. So yeah, the cross ratio EFXD is equal to BCOA. And I'm wondering if that by itself is enough. So we wouldn't need to use involutions. I just so yeah, because whenever you have this many lines that are all parallel, like it almost screams these cross ratio, right? Cross ratios. Okay, so I wanted to show that going back to my old way of thinking about it, I wanted to show that DE and CF cut DX in the same ratio. Well, let me go back to trying that. So yeah, but I don't have a parallel to DX, that's the problem. But maybe if BO is parallel to DX, I think there's a very good chance that the problem would be solved. And I think it is. So, oh no, it's not. Man, I was so close there. Okay. But let's think about this. So AX yeah, is there anything special about point O here? Is ON perpendicular to AX? Let's see. No. Feel like we're very, very close. Okay, so basically we're saying, let's try to prove that. I think you said if you could show that Bm times Bn is Bl times Bb, that would solve it. So that's like the power B with respect to any kind of circle like this. It's just choosing the right one. Let's see, any way to do this? How can I use Pascal's theorem? So maybe XA, DO, and some other points. So XA and DO meet at the point of infinity. Let's think about this. So okay, so what if I project E through these points? See, it's like I want to draw a parallel to dx. We get x, b, d, and this point. So let me think about this. Yeah, it looks like there's too much. Yeah, I just don't know how to finish it. I'll be right back, guys. All right, I see someone put something in the chat. Can AB intersect CB help? Let's draw that. So what were you thinking with this point? Oh, DDIT. Okay. Let's see. So I wonder if an so because of the similar triangles, is it true that PC times PH is PB times PG? I think that might be true. So maybe this is the inversion. So if we draw a circle with center PK.
I think I have solved it,
Okay.
Michael.
Okay.
So we're gonna use the fact that inversion fixes the cross ratio.
Okay.
So if we can show that the cross ratio CBIA wait a second, let me just write this out real quick.
Okay.
So we need to prove that cross ratio FE XD is equal to cross ratio xb dx.
XBD. Okay.
Because we know an inversion fixes the cross ratio. So if you let DF CF meet BE at a point.
Yeah. Okay. So I see how proving that solves it. Okay. So let CF meet BE at a point.
Yeah. So we're gonna do an inversion at point I.
Okay.
So it's gonna transfer F to C, E to B, X to a point X prime, and D to a point
X
D
prime.
prime.
Okay.
So the collinearity happens if and only if the cross ratio FEXD is equal to CBDX.
Yes.
So it is equivalent to I'm gonna write the cross ratio
Okay.
down in the chat. Is actually it is equivalent to that ratio.
Okay.
So it is equivalent to when you just do a little algebra, and it is it's like this. And the last equation is true. It is due to an inversion at P, which swaps B and C, X and O. Wait, so sorry, I have a little mistake here.
Okay. Sorry. So we don't need HM. We don't need any of these points up here.
Actually, it's just a typo because my diagram is a little different. So let me just fix it.
Okay. So O, this is the same O, right? Or is O the center of the circle? But basically, I don't think so. I can, or what?
Yeah, I'm using the O that you drew.
Okay. All right. So I'm going to hide a lot of this. So I don't think your solution uses it. Still want to draw AF though. All right. Now it's, do we need, oh, so we do use P. Okay. All right. So I'm going to type it all out. Just a tiny bit bigger. This away. All right. So thanks for typing it up. So we want to show that those cross ratios are equal. And this would prove do all the spacing at the end. So I'm just going to type out what you wrote.
Don't I think you shouldn't copy the one with the point I in it, because actually it's point O, not point I.
Okay.
Yeah, because I made a little typo right there.
All right. So I will just replace it. I think the rest is the same. All right. Okay, so we want to show the cross ratio FED XD CBDX.
Can you replace I with O in the first equivalence?
Oh yeah. Okay. So that's the same as saying OC, okay, FEXD. OC over OB. So how did you get this is equal to this?
Wait, let me just check my calculation.
Okay.
I'm missing a little step here. So we have another claim that the cross ratio A, wait, let me just.
Oh, is it obvious that BC and P are collinear?
We have the claim that the cross ratio A FEXD is equal to D CBIA, because we have the corresponding line that are parallel to each other. So the cross ratio is fixed because those angle between the lines are the same.
Okay. FEXD DCBIA. So how do we know that the angle between BI, let's think about this. So AFEXD, you're saying that those are the same angles as from B to CBI. So how do we know that because I think if we know that, then that might already solve the problem. AX.
Excuse me, what did you ask?
So you're proving the claim, right? That okay, so AFEXD, let me just read what you wrote, equals D CBIA. Since AF is parallel to CB, AE is parallel to DB, AX is parallel. Wait, how do you know AX? I think there might be a type.
Parallel to DO, I think. Yeah,
Oh, AX is parallel to DO.
Yeah,
and
like I'm just messing point I with point O right now, because I wrote it in my paper, and then turns out it was a wrong point.
Okay. So wherever I is, it should say O. So DCB O. Oh, DC. Okay, so just replace I with O, and then we should be good. Okay. So yeah, that's where we use all those parallels. So okay. All right. So we have that that's true. And you use that. Okay, so that means that this is equal to this, CBOA. So should this be, okay, because this you get, so are you saying CBOA is equal to CBDX?
Yeah, so in the first equivalence, you see that OC over OB over AC over AB is actually the cross ratio CBOA.
Okay, so this is
in the second, yeah, that thing right there is CBOA.
okay. Should I change this to OA? Well,
No, it is CBDX equal to CBOA. We want to show that CBOA equals CBDX.
okay. Okay, I see what you're saying.
Yeah.
So okay, so we know these are true, and then we want to show. Okay, so then these are equal to these two. Okay, and then AC over AB is DC over DB. Well, okay, you rewrote it, and then we have CODB. And okay, so you're using that B, C, and P are collinear. Is that like Pascal's theorem? What do you think about that?
So I'm just define P the original way. So when we'll let Px meet the circle at O, so we have Px times Po is Pa times Pd, and since Px is equal to Pa, then we know that Po is also equal to Pd, which implies that XODA is we know that XA is parallel to OD since OX is equal to AD.
Okay, so an inversion about P, it takes, yeah, it swaps O and X, B and C, and A and B, and so these have to have the same cross ratio. Okay, that's interesting. Okay, so that solves it. I like this. All right, so since these are equal by an inversion at I, basically, so I'll explain in just a second. We see BF, CE, and DX concur. Okay. Because inversion preserves the cross ratio. So this equality right here, basically inversion preserves cross ratio. So if you invert all these 4 points about P, so we have like PC times PB is PO times PX is PB times PA equals, let's say, R squared. If you do an inversion about P with radius R, it takes C to B. So C to B, it takes O to X, it takes D to A and it takes B to C. So these cross ratios have to be equal. So that's how we get that one. All right, so I'm going to move on to the next problem. So that was a good solution. We could try this one. So this is from Iran. We draw the insert. Oh, this one you can't draw the diagram exactly. Like you have to move it. I'm gonna just try another one. How about this one? So we have a triangle ABC, and we draw the angle bisectors. So this one might be easier. Let me draw the end circle. Well, I'll just draw the angle bisectors. So, because we need to know where they meet, BE and CF. Okay. It's EF. And this is I. Okay. And then point N. Oh, this actually looks, I remember doing one problem once with the circumcircle of AEF. I think Anmol, forgot who gave me this problem, but it has like the circumcircle of AEF. So angle IAN is right. Okay, so let's draw the circle with diameter. So yeah, we should probably draw the end circle then. And that because basically, here's why we should draw the end circle. Because IAN is right, sorry. So then this kind of idea looks very familiar. Did I do that right? The circumcircle meets line NI at L. And we want to show the circumcenter of AIL is on BC. Okay, so right now this looks kind of messy. Let's close this. How do we make AIL a little less obtuse? Because right now it's like really, really obtuse. I'm not sure. So NI meets it at point L. And E and F are the feet of the angle bisectors. So maybe it's worth letting EI, because we know that this is harmonic. I wonder if EF, AN, and BC concur. Is that true by harmonics? I think it might be. Yeah. Let's make sure that's really true. I think it's true by harmonics, right? Because this is harmonic right here. And also, since these three concur, then yeah, so that makes sense. So let's say they concur at point D. Pretty sure that would be useful. Okay. So the circumcenter of AIL, That's like a huge circle. It's a thing. Oh, maybe it's not as big as I thought, but it's kind of big. Let's draw the center of it. And it lies on BC. So I think I want to let the perpendicular bisector of AI meet BC at a point, because then we could use, so I like the idea of using the in center X center lemma. Basically, if we draw like the perpendicular bisector of AI, I wonder if GL is tangent. So basically, these pass through these points, right? Because AJIH is a kite. So I think we want to use that fact. So AJIH is a kite by the in-center X-center lemma. What do we get if we draw this tangent? Yeah, I think GL might be, it looks like it, yeah. We show GL as tangent. So yeah, we don't even really need this circle. We just want to show GL as tangent. Well, GL and GA are both tangent, but I think we could probably use harmonics to prove GA is tangent, right? So this looks a lot like another problem I did on Discord. Let's see. All right, so it looks like Marco just rejoined us. So yeah, we know GA equals GI. We need to show it's GL. So yeah, we want to show AL is the polar of G. And I wonder if we could do it. Yeah, what was the point of, let's see, what was the point of N again? The angle. I mean, it might be easier. Might be easier to just let these two circles intersect at L prime.
How do we know that GA is tangent?
Do we know that GA is tangent? Is that what you're asking?
No, yes.
I haven't proven it. I think I did it on in Discord previously. Let me see if I can remember how I did that. Well, so GAI is equal to GIA. And we want to show, yeah, maybe it's worth. So we want to show GAI. So that problem I did on Discord previously, I think I drew them, like I let AI intersect this arc at a point. So maybe that'll work here. It's just going to be really close to point L. So let's think about this a little bit. I have to zoom a lot to get that point. There we go. Okay. All right. Oops. So I think like when I saw that problem on Discord, which I like try to find angle GAK. So angle GAK is, we want to show that's like AEK, which is AEB plus BEK. Okay, so K is the midpoint of EF, of arc EF. Yeah, so it might be an angle. It might just be. So we want to, my idea is to use that GAI equals GIA. And then GIA, you could try drawing this point right here. It's like MIA minus MIG. So yeah, let me look on Discord because I know I did this in the past. I'm just curious. I'll see if I can remember the proof instead of looking it up. But I think I proved there that GA was tangent. Pretty sure. I might have used some similar triangle in the process, which I don't remember. So angle AEK. Is there a way to just compute that?
No.
Well, I think it's not that hard to to calculate angle AEK, because that's just angle AEF.
But you don't know AEF.
But we could, oh, AEF. Yeah, there's no easy way to calculate angle AEF, is what you're saying. But if we know that GAI is GIA, then maybe we could calculate it in terms of that. So that's kind of what I'm thinking.
We need to show that GI is parallel to EF in order to
Yes.
prove that GA is tangent.
And that's exactly what I proved in that problem on my Discord, that GI is tangent GI is parallel to EF. Yeah. So I did this before, I just don't remember how I did it.
Maybe projective geometry. We project something because we have parallel lines.
I think yeah, we could use it. Anmol sent me a solution. I came up with a solution, and then I think I3435 had his own solution that just used projective GEO. We had 3 solutions to this, and I can't remember one of them. But yeah. It was a long time ago, so yeah. I'm gonna scroll back in the Discord, see if I can find it. Let's see. All right. Yeah, that's what happens when you get older. You just can't remember anything. I'm not that old, but not as good as I used to be. All right. I think I might have gone too far back now. Actually, maybe not. Or what I could do is I could search the emails I got from Anmol, and that would probably have the date. Yeah, you want to try a new one? Okay. But yeah, so yeah, I know in the past I've proven this. So yeah, I'll open up a new one, and then I'll see if I can find, in the end, if I can find the solution to that, I'll type it up. So we have a triangle in center I. Okay, another problem with the orthocenter of BIC. So basically that point makes a parallelogram with the X center. So we've seen this come up a couple times. Whoops. Okay, so T is the Q point. So we just intersect those circles. E, this is T. Oh, sorry, T is the Sharkydevil point. And then whoops, that's not what I want.
We did this on the previous session.
Oh, we did?
Yeah,
Oh yeah, okay, it's the same problem. That's what I'm looking
exactly this one.
at. Okay. All right. I think we finished with this one, so we could try this, right? Because I don't think we solved this, but I think I drew it up, right? Circle BIC. Okay, so we know the midpoint of that is the midpoint of arc BC. And okay. Both, I think it's both perpendicular to BC. Oh, but we were trying to figure out which point, I think we asked this last time, which point is E? Let's just draw, okay. A. So we know this is D, but which of these is E? Let's just pick one. Oh, they lie on, okay, E lies on, okay, that's what I got confused. So E lies on this circle. Wait, D lies on this and E lies on this. And then if M is the midpoint of BC, we can just reflect F over M. So this is M and reflect this is F. Oh, I gotta call this something else. Okay. Okay, so we need to draw these 2 points. This and this. This is N. What is G? G is the intersection of DE with, this should be G. I want to show that GM and NF intersect on the circle. Let's give this a name. That'll be H. And I think I have enough to do this. Okay. That looks good. So yeah, F is the reflection of K across M. We also have, obviously, AF passes through the topmost point in the circle. That is our favorite lemma. Make it just slightly bigger, not too big. All right. So yeah, I don't know if it's worth drawing the X circle. But yeah, we want to show that this and this concur on the circle. That's the same as trying to calculate the angle between them and showing it's like angle GHN. So that's another, but that might be just as hard. So.
G looks like to be the Sharkydevil point.
Oh, really?
Yeah, and we can, if we prove that, then we are done, basically. You can use butterfly theorem to
Okay.
finish it.
All right. So we need to show G is the Sharkydevil point, and then the butterfly theorem would do it after that. All right. Because let me think about that. So
You use that GKH or linear.
oh yeah, that's right. And then, yeah, then it's the butterfly. Interesting. Okay. So maybe we could let G prime be the Sharkydevil point and then show that G prime E and D are collinear. That's one way to do it.
Maybe we should use the fact that G prime K and AE intersect on the circle.
Okay.
I believe that's some angle chase.
Yeah. I think I proved it in my video. Yeah, I think I proved that fact in my video on the Sharkydevil. Yeah, it's just an angle chase, I'm pretty sure. But yeah, like you said. Oh, whoops, there was already an L called P. Hmm. Um, I can't find that email that Amel sent me. I'm gonna keep looking for it. Besides this problem, or just another problem in general? Let's try to finish this one first. Just because I don't want to start another problem because I feel like we're really close, but. Okay. Right. Sorry. Any second I'm gonna find it. I'm just looking through all my different posts. Let's see. Oh, June 2nd of last year. So not June 2nd of this year. That's a long time ago. Oh, I see it now. Oh, I did a post on May 26th of it. Okay. And yeah, it was basically the same idea. So yeah, if you guys want, once we have 10 minutes left, I'll type up the solution to that other problem. So actually, I think that parallelism isn't hard, but the tangency was maybe a little harder in that last problem. All right, I'm going to focus on this for the next 12 minutes. Let's see. So we want to show that G prime E and D are collinear. Which is the same as showing G.
This looks like something I should already know, but it's just surprising that I haven't seen this before.
Yeah. P prime almost looks like the ortho center, but it's not. So yeah, we can try to show that PE over KD is G prime P over G prime K.
The only problem with that is that we basically don't know any of these segments.
Well, like KP times KG prime is K. Oh, but J doesn't lie on the circle. Yeah. Yeah, we don't know enough of those. So yeah, if you connect the Sharkydevil point to this point, then apparently it lies on IK. That's interesting. So we could draw a few of the other things we know about the Sharkydevil point. I don't know which ones will and which ones won't help, but what do we know about it? So I think, like, if we draw the tangent from I to both circles, I think it passes through that. And then I think there's some things about this point. So this is a cyclic quad. And I wonder if we draw that. I think, yeah, these are parallel.
We want to show that G prime K bisects the angle DG prime I.
J prime I?
G prime K bisects angle DG prime I.
Okay, DG prime I.
That would be sufficient.
All right.
Since G prime I passes through the the diameter point.
Okay. Yeah, I should draw that point. That's probably the most important fact about the Sharkydevil, and I didn't draw it. So let me delete some of the other stuff. I'm just going to use that fact. But yeah, I guess that's kind of an obvious fact, because this is the right angle, but still, it's important. I guess the other fact is if you take the perpendicular from K to OL, then so yeah, I'm going to delete this point right here, even though I added it before.
Oh, intersect G prime N with DI.
One sec. G prime M.
D prime I with G prime N.
Okay. So you said G prime M, right?
G prime N.
Oh, sorry, G prime N.
Then we have to show just one harmonic bundle and we are done.
Okay. Basically, we need to show that this is cyclic.
Which one?
Or
No, not sure how to prove that. Doesn't look too hard, but we need to show that DIKX is a harmonic.
okay. Okay, DIKX. And if we project through G prime, that's the same as saying PIX and this point is harmonic. Let's call this Y. So PYXI we want to show is harmonic. And then we could project through G prime onto the circle. So we want to show that EHQN is harmonic, which is obvious. So that solves it.
It doesn't.
It doesn't.
You assume that G prime E and D are linear.
You're right.
That is why we need to show that it is harmonic, since you will get that projection.
Yeah. Okay. Okay. So it's really the other way. So XIKD. All right.
I think we should project this cross ratio through the X center onto BC.
Okay. So if we did that, okay, so K, so I would go to this point, right? So let's see. So this is the X center right here. So D goes to infinity, I goes to G, K stays at K. And X, we want to see where X goes. Okay, so we want to show that basically G is the midpoint of KS, right? So R is the X center. So yeah, obviously this is a rectangle. Yeah, that point X is tricky. So maybe, so wait, XI, KD. wonder if there's another way to do this. So xi is equal to AP. Yeah, these are homothetic about I, these two circles. Yeah. And these are similar. It almost feels like, like we should have enough where we could bash that, it feels like. So xi over xd is ai over ar, right? So we want to show ai over ar is equal to ik over kd. Because we have so much similar stuff. Ik over kd. So ik over id is ig over ir. Yeah, but ig is a little tricky to get. Ir is just twice the radius. Feels bashable. You just need ik over I over kd. Oh, and kd is the x radius. So yeah, we just have to show the n radius over the x radius is ai over ar, and that's trivial. Yeah. So yeah, it's true. Yeah, it's basically so xi over xd is ai over ar, which if you drop perpendiculars to AB and AC, that's the n radius over the x radius, right? And then ik over kd is also just ik is literally the n radius, and kd is literally the x radius. So that proves it's harmonic.
Could you repeat again?
Yeah, sure.
Xi or xk?
Or xi over xd.
Yeah. Okay, just one thing we need to prove, which is still left, is that x is on the circle.
X
doesn't look too hard to prove, but we still
yeah.
haven't proved it yet.
Yeah, because we defined x to be the intersection of n g prime with a circle.
Well, it depends how we define it, but we need to prove that those three are concurrent.
All right. So we have to show I mean, even if we define it this way, it's kind of because it's just all right angles, right? Like if we just let G prime n meet the circle at a point X, then this is a right angle, so this has to be a right angle, right? I guess I'm saying like I think it's obvious that, or like if we just let these intersect at X, then since angle NG prime H is 90, XG prime P is 90, right? And so that means XAP and XIP have to be 90. Oh, but we need to show XJ and I are collinear. So let's see.
But IP is 90, so IP is parallel to BC, so isn't that done?
That's enough.
Yeah.
I think so. Yeah, because we know if we know this is 90, yeah, then yeah. So I think we're good. Like I think we have enough information. So I'll just say label the points as shown. Just to type it up quick. So let G prime be the Sharkydevil point. Then we have G prime, P, K, and H are collinear. That's well known. Okay. Then AI over AR is equal to, so XI over XD is AI over AR. Equals R over RA, where R is the in radius and RA is the AX radius. Okay. And then IK over KD equals IK over FR, which is also equal to R over RA. And that implies the harmonic KIDKX is harmonic. And then we take those and we project it through G prime. So XIP and GD intersect the circle is harmonic. G prime D intersect the circle diameter AI or harmonic. Should we name that point? Let's see. So let's call it S. And then projecting onto G prime to ABC. N G prime B C, call it Y. Why not? Or E prime. And then Q H is harmonic. Harmonic implies E prime equals E. And that means that GM all right, so that is that. How much time do we have left? 1 minute. Let's see if I can remember. So okay. So I'm trying to close out of this. Let's see. Here we go. This problem. So if I look, so first, let's see, I showed that it's, so AD is parallel to JH, obviously. That's pretty obvious. But then, what did I do before that? I try to show that EF is parallel to GI, and let me see what I did for that. So I don't think I'm going to type the whole thing. Okay. So this angle is equal to, so angle GAK is equal to angle GAI is angle GIA. That's the angle between GI and AI. Oh, and that's, okay, so angle GIA is actually the angle between EF and IA. And the angle between EF and IA, that's the angle between EF and AK, which is half of arc EA plus half of arc FK. And we know arc FK, it's half of arc FE. And arc AE is basically, I think once we know that GI is parallel to EF, then angle GAI is angle GIA, but GI is parallel to EF, so that's the angle between EF and IA, which is the angle between AK and EF. And then I think you can just calculate stuff. But then there's still one more step. So we could prove these are parallel. Sorry. That proves that those are parallel. But then you need one more similar triangle. So, but let's see. So I took I labeled all the points with different names in this figure, so that makes it tricky. But I took a perpendicular from B to AI apparently, and that helped me show. Okay. I'm not going to finish. I'll just let you guys see if you can finish it. But yeah, I can show that GI is parallel to EF. So that's pretty much it. So yeah, thanks everyone for hopping on again. So this was a fun session with a lot of good ideas, and I will see you next time. So for everyone watching on YouTube, if you want to join us in the future, feel free to email me at mgreenb801@gmail.com. It's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. So thanks and have a great day.